Hello everybody. In this video, we're going to do a quick introduction into solving linear equations. Make sure you share this document with me and make sure you put your name or initials here in your title. What is the goal of solving an equation? Well, our goal is to find the value of the variable in the equation. And we want to answer this question: what number is the variable equal to? Why can't we just automatically see the value of the variable? Well, there have been some operations done to the variable, and these operations cause the value of the variable to change. Let's take a look at an example. We start with a variable x that equals 2, and then we multiply x by 3. Well, now the value of this equation is 6. And then we subtracted 7 from this equation. So now the value of the equation is -1. So this equation here is equal to -1. But remember, x began as a value of 2. And so whenever we're doing these operations to a variable, we are adjusting and we're changing the value. So how do we find the original value? Well, we need to undo all of the operations done to the variable. So we can think of solving linear equations as using operations to find the value of a variable. Well, what are these operations? You know these. We have the operations addition, subtraction, multiplication, division. We have exponents and we have radicals, and these things might be new to you. So if you have questions about exponents and radicals, you can ask me. So these operations can change the value of a number or the value of a variable, and these operations must follow the order of operations. Well, what is the order of operations? The order of operations is the order we must do these operations in to simplify an expression. So there's rules around the order we have to operate in. Well, how do we know what that order of operation is? We have the acronym PEMDAS, and you might have heard this from your middle school math. PEMDAS stands as a representation of the order of operation. So the P in PEMDAS stands for parentheses. Anytime you see a set of parentheses, you're going to do the operations inside the parentheses first. E stands for exponent. Exponent is repeated multiplication, and it's the opposite of radicals. So earlier we talked about exponents and radicals. These two things are opposites of each other. Once you've done any exponents, you would do any multiplication. And of course, multiplication is just repeated addition. Once you've done your multiplication, you would do any division. And then you would be able to do any addition in the equation. And then last, you would do any subtraction. So we use PEMDAS, PEMDAS, to help us remember that when we are simplifying, we have to follow this order of operations. So when do we use the order of operations? Well, I just mentioned that we use the order of operations when we simplify an expression, when we solve an equation, and anytime we're writing in math. The order of operations allows us to share our work with other people, even if they speak other languages. So I can write down some mathematical ideas and spread that across the world, and other people would be able to read it and understand it. This also keeps us in line with the rules and structures of algebra. So we have to make sure that we are following the rules and structures of algebra so that everything remains true. Let's practice identifying the order of operations in each example. So this first example, we have inside a set of parentheses, -9 divided by 3 to the power of 2. And so since we have a set of parentheses, we're going to do the operation inside of the parentheses first. And so our first operation is division. We would do the division inside of here first. Our second operation would be this exponent with this power of 2 exponent. We would do the division first, and then we would use the exponent. In this example, we have some addition happening inside the parentheses. So the first operation would be addition inside the parentheses. Then, after we would do that division, we actually have this 2 is being multiplied by the parentheses. So then we would do the multiplication. Multiply by 2. And the last operation would be this negative 10 plus. So then the last operation would be the addition by negative 10. So this is the order we would take to simplify this expression. Now here's an expression or an equation that has a variable in it, but we're really just looking at the right side of this equal sign, because on the left side there's no operations going on, we just have a negative 12. So we're really just looking at the right side. The first thing I see is a multiplication here, 12 times x. And so the first operation would be multiplication, and it's 12 times x. And then after we did that multiplication, we would be able to do the addition at 36. In this example, we have addition by 1, we have some division going on, and we have some multiplication. And so the truth is, multiplication and division can be done in really any order. So the first thing we would do here is division. We have negative 42 divided by 6. And then we would be able to multiply by 3. So after we've done that division, we can multiply by 3. And the last step would be addition by 1. Let's look at 2 more examples here. We have an equation here that's equal to a negative 4, and there's no operations happening to a negative 4, so let's focus on the left side of this equation. We have 2 times b plus 6, and so the first operation that we would do would be multiply 2 times b. So we would do that multiplication first, and then we would subtract by 6. Our last example has an exponent in it. It's also an equation. On the right side of this equation, there's just a 44. Nothing's happening to 44, so let's focus on the left. I see a set of parentheses, so we need to do what's inside of the parentheses first. So inside of the parentheses, we would do x plus 8. Then, after we've done the parentheses, we would do the exponent of 2. Once we've done that exponent, then all we have left is to subtract by 30. So all of these examples, what we've done is we've gone and looked at the operations happening, and we've placed those operations in the correct order. The order that we're following for all of these examples is the order of operations, which is here. So if you need to reference the order of operations while you're working on these examples, please do so. Anytime we simplify an expression, we follow this order of operations. After you complete these notes, go into the Delta Math practice activity called Order of Operations. Let me know if you have any questions about this video or any of these examples, and I will come help. Thank you for watching. Don't forget to like and subscribe.